So different types of proteins that I have. Channel proteins, very good. All right. What was that? Transport proteins, very good. What?
The carrier?
That's a transport protein.
The marker one.
Yeah. Major histocompatibility proteins or
The ligons?
what was that?
Are those the ligons?
Ligands? That's a receptor protein.
That thing.
Yeah, the ligand is not a
Ligand.
protein, right? It's what it binds to, but the receptor protein is what accepts the ligand. Okay? So it sits there like this, waiting for the ligand to bind, and then once it binds, then it can cause an action inside the cell. Okay? So that works better. I don't know, you guys may notice that I do a lot of weird body movements sometimes, but that's how my brain works. Okay? So yeah, that's a receptor, and that's going to cause an inside change. So that would be something like that would respond to like hormones, right? What else? What gives my cells shape?
Membrane?
And that's what you were talking about, this, like, if you had the structure.
Oh, I just read this last night.
Itself, right?
Is it the nucleolus?
No, the nucleolus is the genes of the cell.
It's not the nucleus. It's the nucleus?
It's inside the nucleus.
No,
I
that's
remember
nucleus.
telling us about it. I just can't remember.
It's called the cytoskeletal anchor. Yeah, cytoskeletal anchors. So they just hold the cell in place and keep it the way it's supposed to be. That's how come you can get things like columnar epithelium, right? Because then the cytoskeletal anchors are going to hold it in that shape. That not every cell is going to be round. So if it was round, that's the easiest shape of the cell to maintain. So you need these structural elements in order for it to be able to adapt to different types of environments. Okay? All right. Good. I don't know. You guys ask me some questions.
I think we asked it again.
You answered them.
Yeah, I think you answered them all.
So
Nice try.
I don't
know.
I can't think of it. The stroma then is located where?
The stroma is like an extracellular matrix. Okay, so that's basically what your connective tissue is. Okay, so that's basically your remember reticulin? Okay, the reticulin is the connective tissue structure in which the cells live.
And the cell membrane is, or not cell membrane, the basement membrane, that's connective tissue?
That's epithelium.
Epithelium. Oh, I thought it was some sort of...
It's only with epithelium.
Okay.
All right? Connective tissue does not have basement membrane. No, basement membrane and epithelium sit on top of connective tissue.
Okay. I got it.
When going back to the bones and right off of the cellular, with like the differences between the cervical, thoracic, vertebrae, like the lumbar, all of that, do we need to know, like, okay, the transfer, like if we're looking at a picture, that's the transverse, that's the spinous process. This is the, I can't remember what
The
it is.
segment or super large.
Yeah.
People
So
body.
we need to know the structure of the bone like that.
Yeah. It's a lot of information, I'm not going to lie to you.
Yeah.
Okay?
I'm racking my brains trying to think what I was going to ask.
Yeah.
I don't even know enough about the cellular to ask questions.
Well, with the cells, okay. What are the different organelles in the cell?
Like
The
stuff like the
Yeah, and the less
mitochondria.
reticulum.
Smooth and rough.
Smooth and rough. Okay, so what's the difference between the two?
Rough has ribosomes.
Rough has ribosomes, which means it does.
It
makes
synthesizes.
proteins. Right.
Yeah.
Synthesizes proteins from messenger RNA.
Yeah.
Right? Do you remember what that process is called?
Yeah. Oh, crap.
Remember the monks? When I talked about the monks?
No.
Okay. When the monks are in the AVI, okay, back in the 1600s, and they're translating stuff, right? If the monks are copying from Latin into another Latin version that has transcription.
Yeah.
copying from Latin into German or English, that's translation, okay? So we go from something that's in a nucleic acid format to something that's in a protein format, so that's translation, okay? If we're going from DNA, reading DNA to RNA, those are still nucleic acids, so that's transcription. It's just a different guy is writing it. See what I mean?
Okay.
So that's the difference between the two. Okay? So where does transcription happen?
In the cytoplasm?
In the nucleus. Yes. In the nucleus is where transcription happens because that's where DNA gets made into RNA. Okay? And then in the rough endoplasmic reticulum where the ribosomes are, that's where protein is manufactured from messenger RNA.
So that's where
That's translation. Right. Okay? What happens in the mitochondria?
the powerhouse.
That's the powerhouse of the cell.
Produces
Right.
ATP.
ATP, very good. And so what kind of processes are going on there? What do we call that process that happens in the mitochondria?
Oh, I knew that and I forgot.
Hmm? It does, kind of, but it also has something to do with other things too.
Is that what we were just talking about where it was the transport? Is that transport?
No, it's respiration actually. Cellular respiration happens in the mitochondria. Okay, so that's where oxygen gets made into products. Okay, burning of oxygen. Okay. How about the nucleolus? What's going on there?
Makes RNA?
Nope, you're
No.
making RNA in the
DNA.
nucleus.
DNA.
Yeah, that's the DNA is living in the nucleolus because that's the genes.
Yeah.
Right. Okay, so cellular reproduction would happen in the nucleolus, right? Good. Okay, how about lysosomes? What's going on there?
They filter.
Hmm?
Breaks and
Like the garbage disposal.
It's garbage disposal unit. Yeah, it's basically stuff like cellular digestion happens there. Okay, so that's where all your enzymes are. Am I missing anything? Golgi body.
So it packages the.
Yeah, that's UPS.
Yeah.
Right. UPS, packages and transports. Okay, so that's what that does. Yeah. Thank you. How about smooth endoplasmic reticulum?
It's also a translator, right?
Translation? No. Translation does not happen there because there's no ribosomes.
Okay.
So, but what it does is it assists the Golgi body for transport, okay? And it also takes care of calcium storage in muscle cells. Okay? So who can tell me about charge differential across the cell membrane? What do we call that? Oh, not transport. What would you say? Membrane potential is absolutely right. Okay, and what is that? I heard it. I just wasn't sure where it came from.
Make sure it's recorded. Shape it up.
Yeah, membrane potential.
Hmm?
Okay.
You can
So
get
what
it.
is it?
Okay.
Yeah, it makes maintenance of charge across the cell membrane. How do we do that? Ions, right. So we have larger ions on the inside of the cell than we have on the outside of the cell, so we have a relative negative charge. Okay? So that's how that works.
What is it? What is it? Hypertonic and hypotonic? Did we go over that yet?
A little
it's
bit, yeah.
cell busting.
That's osmosis.
Osmosis. That's
Right. Yeah, that's why I said if you remember that picture better, just describe that picture if I ask about osmosis.
Okay.
If I ask you to describe it, okay? Don't try to give me the book definition. Explain it because that way I know that you understand the process. Okay? It's just that you couldn't articulate it in book fashion. Okay? But you'll still get points for that.
Okay.
All right? Don't be upset, Dominic.